Well, this is the roundup for Chapter 11. Let's get rolling. We're going to be talking about expected value, which you can think of as average value or typical value. We've talked about something similar to this in the past. Let's get rolling and wrap up this chapter, okay? Compute expected value, solve some applied problems, use it to find the average payoff or loss in a game of chance. So what is expected value? It's a mathematical way to use probabilities to figure out what's going to happen if you do this for a long time or for many times. It's used for insurance policies. How do they decide what to charge you for an insurance premium? You can weigh the risks versus the benefits in business ventures, betting ventures even. Indicate to a player of a game of chance and a gambler what will happen if they play it repeatedly, a lot of times. Okay, here's one to write down for the record. This is the standard way to compute expected value. Multiply each possible outcome by its probability. Once you've got all those products, add those products together, and that will give you the expected value or the typical value or average value that you can expect over the long haul. Excuse me. All right, let's do this. Let's use as an example the expected value for the number of girls for a family with 3 children. First of all, 3 children, you can have 0, 1, 2, 3 girls. 8 ways that can happen. Consider it like flipping a coin. There are 8 ways you can get a result of flipping the coin 3 times. Here are the possible results. No girls, 0. 1 girl, 2 girls, 3 girls. And those are the results. You might say those are the x's. And we're also going to be looking for the probability for each of those x's. Because what we're going to do is we're going to multiply those 2 together. And then at the end, add those up. Sigma means add them up. So you can see that the way to get no girls is if you have boy, boy, and then boy. Only one way that can happen. 1 girl, well, she might have been the first one, or the second one, or the third one born, and so on. You can see that for yourself. The important thing is that we've got 8 different possible results of boys versus girls in 3 births. That'll give us probabilities. For no girls, you have 1 chance out of the 8. For 1 girl, you have 3 chances out of the 8. For 2 girls, also 3 chances out of 8. You can get that just from your picture. And all girls, 1/2 times 1/2 times 1/2, or 1/8. Sorry, this is a little bit messy. So we're going to take each outcome. These are the outcomes here. 0, 1, 2, 3. Each one will be multiplied times the probability, which we've got here, 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 and here. So 0 times 1/8. That was 0 girls times 1/8 probability. 1 girl, 3/8 probability. 2 girls, 3/8 probability. 3 girls, 1/8 probability. Do the math, and your expected value of number of girls with 3 births would be 1.5. That sort of makes sense, doesn't it? So if we looked at a lot of 3-child families, a lot of them, the average number of girls would be 1.5, or half the children. Let's take a look at insurance. You might find this interesting because this is how your premium is calculated, pretty much. So these are the possible claims: 0, 2,000, 4,000, 6, 8, and 10,000. And here are the probabilities for those individual results or claims. And all you need to do is multiply each of these together. Here will be your claim times the probability of that claim. So for this first one, 0 times 0.70, that's simple, 0. For the second one, 2,000 times 0.15, which would be 300, I believe, and so on down the line. So multiply all those together. Each of these is a result times the probability of that particular event. Add all those together, and this would be the expected value that any one client would claim during a particular year. So you want to average at least $1,100 per premium. And that's only to break even. Of course, that also means that you got to charge more than $1,100 because you've got the company to continue. You've got to pay the agents and so on. How about for a game? This might be another way of looking at it. Multiply the gain or loss. That's important. Figure out what the gain or loss is. That's your outcome. Then add those products. Sound familiar by now? So let's see. We're going back to the roulette wheel again. And we're going to bet $1 on the number 20. If it lands on that, you get $35. Hey, that sounds pretty good. You want to play? And you also get to keep the dollar that you paid. You get that back. Remember that, because you get 35 and you get the dollar back, so your net is 35. If it hits on any of the other 37 slots, remember there are 38 slots altogether, you don't get any money, and you have to pay that dollar that you bet. So, playing one number, you're going for a 20. So the ball lands on a 20, you get 35. You don't have to subtract the 1 because they give it back to you. There's only one chance out of 38 of hitting that 20. So you're going to multiply those two together. If the ball doesn't land on the 20, you lose your dollar. And that'll happen 37 out of 38 times. So multiply those two together. Take the number you get here, not a 0, and the number you get here, add those together, and that will be your expected value. What's it look like? There's your 35 that you won, and there's the probability that you actually get the $35. And there's the $1 you bet where you lost, and that happens 37 out of 38 times. Do the simple arithmetic. This is your typical result of playing that game with the roulette wheel. If you played this a lot of times, you'd average losing 5 cents every time you played. And that, folks, is expected value with a couple of examples thrown in, especially the insurance one. That gives you an idea how that number shows up in your insurance premiums. And that, of course, could be life insurance, auto insurance, any insurance. That's basically how it works. Well, I hope you got some enjoyment out of Chapter 11. Next time we'll be hitting statistics, and we'll be setting you up for Math 102 success. In the meantime, you take care.